And there you go, Tim.
Okay. What do you see?
We see your
my
screen.
notes, perhaps, hopefully.
Slide notes.
Yeah.
Yeah. Okay. Try one more step here.
Timmy Neutron.
Yeah, saw that. So did the MD4000 make an appearance here?
Yes.
Golly, I can't find my cursor at all. Okay. We're ready. So, first of all, welcome back. Hopefully you came back for part 2. I want to, we're going to do a lot more hands-on stuff today. Yesterday was kind of fun, perhaps, maybe. I was trying to convince Jeff how to become an electron, or how to look at electricity through really kind of being in the wire. And we talked a lot about expectations, about if you were an electron and you could see through the wire and see what kind of resistances, whether it's good or bad. If you could see ahead of time, you would somewhat ration your voltage out as you traveled through the wire to make it back to the battery. And that's the old law of dropping, the sum of all the voltage drops equals the circuit voltage. And so just trying to kind of put a little bit of a human aspect on it where, with the idea that if you have an expectation, and as we teach this to students, if they have an expectation, they're just going to be better at diagnosing. So I think if they can visualize what to expect, even if it's a matter of acting like you're going through the wire, you are an electron and you're going through a wire, then whatever it takes to help them understand it. And, there's been a few discussions here on some of the other platforms about what's really needed as far as training and while I understand electricity is a lot different today than it was perhaps when I was earning a paycheck, and CAN bus and things like that are new wave. The way to go. I think you need to understand plus and negative and electrons before you get into ones and zeros. So, we talked yesterday quite a bit about you have to visualize it from your student's point of view, where everything that we're talking about is a new vocabulary, and you can't assume that they know the stuff that we know. So how do you get through to them? How do you get them interested? How do you not scare them off? And that's kind of what I'm trying to present this week. So talked about electrons moving, becoming the electron. Electrons have to go through a wire, perform some work. I said I was an electron. I'm a workaholic. I like doing work. So I'm on the hunt for it. I go down there, I find the work, I do it, and I go back to the battery. Must return to the battery. And it's just like, me. I must return to the battery. What is voltage? What is voltage, Jeff? I'm giving you the answer.
Are you?
Yeah.
Oh, it's potential energy. I used to use the water analogy, and probably I shouldn't say what I used to say, but it's back behind the dam, and it's potential to go somewhere. So anyway,
it's back behind the what now?
Actually, I would joke with the students and say it's the water behind the dam. So
yeah.
It's potential there to roll, but that return is where that breaks down.
Yep. Yeah, we said that yesterday, that that water model was really pretty cool about explaining, I think, potential voltage, amperage, the movement of electrons or current, and then resistance being the dam, perhaps. But it was like once it made it past the dam, how did it get back to the water tower to start the circuit again? And that model seemed to kind of fail in that explanation. So,
one thing I used to use, Tim, is I'd have a student. We talk about potential, and I would say, okay, try to push my hand. Don't actually do it, but try. And that's the potential. It's there, it's ready, and as soon as we have current flow, you can push the hand.
Yep.
Or roll the rock.
Say that about it. There you go. used to say that about the test. You have potential to pass this test, whether you do or not.
Right.
So yeah, voltage is really how strong am I? How much work can I do? And we're going to go kind of explore that today. I want to pound one more thing home before we go to the trainer, just because it's part of where we're going today. So if you have a dead battery, I'm telling you that as an electron, I'm not dead. I'm just probably dead tired. The reason why we can charge batteries. Russ was talking about that a little bit before the event here today about a electric bicycle and rechargeable batteries and stuff. He's gonna wear out some electrons, and he's gonna recharge them and reuse them. So we got picky yesterday saying a fully charged battery is 12.66. Again, we could do a whole session on batteries, but I love saying, trust me on this, it's 12.66, and it's not just 12 volts. So, I mean, I may say that in my quick explanation here today, but 12.66 is what we're looking for. And so the end result is always start with a battery. So I promised Jeff I was going to show him something today, and he kind of knows this. It's something I think that he taught. I think you taught probably at Bellingham. I mean, we were pretty similar in a lot of what we were doing there. So pretty much and this is a great strategy, I think, to send your students out with. I mean, it's just like a tool in the box. If you give them something, some kind of test to perform that is consistently dependable, then they have some confidence, whether they're not going to be a master technician just because they know this, but they at least have a direction. I said yesterday, we could hook a meter up to a lot of stuff and get numbers to appear magically. If we don't know how to interpret them, then it means nothing. So what do you think first step is in a three-step electrical test?
Well, I need to know that I have source voltage. The basics of the system, the root of the system is the battery. And if we don't have a battery, if we don't have a good battery, what are we doing? So we have to establish that.
I know that, whatever, I'll admit it, and hopefully others will, that, I've chased my tail quite a bit on cars, and it wound up being just overlooked the battery, and so.
That's why I'm so adamant. I've been caught on that one.
I've used to have fun when we were teaching with like the 1919s, because you can mess with the source voltage. There's a knob on there, just like this MD4000. And I would go over and just casually talk to them and put my hand on it and kind of slide the battery voltage back down and move on. And they'd be doing their testing and get real frustrated because they weren't getting good results. And I felt mean that I did it, but it was trying to, they'll remember that, I guess.
Mm-hmm.
They won't forget to keep an eye on me and then check the battery.
Well, and I
so
think
go ahead.
You have, once again, we talked about accuracy. You've prefaced hopefully your class has been prefaced with accuracy is going to be important. You establish that shock tolerance. My shock tolerance is this, whatever you decide. And I'm hoping that it's 2 or 3 points past the decimal point.
Yeah. Well, I used to tell my students, I want you to be the guy that goes to the parts department and says, I need one of these, not let me try one of these.
Yeah.
And there's a big difference. And as a shop owner, if a guy came up and gave me a diagnosis and carried it out to 2 decimals and was able to tell me, where we're going today, he could pinpoint where this failure is more accurately. And the second guy came up and said, it's got a bad ground. I'm probably going to sell the work for the first guy and tell the second guy to go back and spend a little bit more time. So if we have a circuit, and today we're going to do, most simple, it's a switch and a light bulb. If we have a light bulb lit and we want to know if it's functioning as designed, as engineered, as efficiently as it can, where would be the next place to test? And we're talking voltage here.
Well, I want to go to the load. I want to go to the thing that's either that's the trouble. Okay, I got a dim bulb. I want to go to the load or as close to the load as I can. And then I got to choose, right? So on either side of the load, I'm going to test for voltage, source voltage before the load. And then after the load, I want to check my ground to make sure that I have sufficient ground in the system.
So we're looking. So, back to the little imagination, as an electron, I was looking down the wire from the battery, and I see the load, and I don't see any problems going to the load. I mean, the wiring looks fine. There's no corrosion or connection. I get to the load. I arrive at the load pretty close to source voltage. I mean, we all know that different diameter and different lengths of wires require, I guess, have a voltage drop just by design, but it's very minimal. Your job is to apply or get to the work that was designed to do, the bulb, and arrive there with as close to source voltage as you can. And that's the work that I wanted to do. I'm a workaholic. That was the deal. I want to light that light as bright as I can, and I want to save just enough when I get out of the light bulb, when I pass through it after doing the work and changing my voltage into in this case light. I want to have enough to get back to the battery. And that close to zero is something we'll look at here real quick. So,
good.
Matter of fact, let's look real quick. Just verify with me that you can see that, right?
Yeah, we've got the MD4000.
Okay, this is, again, our modular electrical trainer. I like it for a lot of reasons. I like it because we're simply looking at what I'm talking about today. In the world of distractions and, ADD, ADHD, Asperger's, the whole 9 yards, I think it's important when we're trying to teach a fundamental that we don't have a lot of distractions around. And so in this case, I've got a battery, technically, a power source, and I've got it set. I can adjust it. I'll show you here what we adjusted it to in a minute. And these are basically the battery cables coming out of the battery. And so I'm going to make a circuit. I've got a switch. I actually have 2 switches. I'm going to choose one. It's just a single pole, single throw switch to turn a light bulb on and return to the battery. Fair enough?
Yep.
So power 2.
The most simplest of protected circuit.
Well, and actually this has a circuit breaker on it. I would like to have a fuse in here too, but I'm still trying to keep it so simple today that I'm just trying to get the concept down, and then we can layer into it here as we go. So down to a switch, and then we need to come out of the switch, go to the bulb, and then we're going to return from the bulb to the battery, because I say we have to return to the battery. Actually, I'm going to go like this. So, to the switch, potentially through the switch, not yet, to the bulb, through the bulb, to the ground. And I always like explaining it like that because I think it helped them follow that visual of your electron. I'm coming out of the battery to the switch, through the switch, to the bulb, through the bulb, to the ground. And then so they've kind of made the whole trip. So if I flick this switch, it should light, correct?
I would hope.
Or embarrassingly, it won't. Okay, it will. Yeah. Okay, so where I'm going today is, excuse me, that's a simple circuit, and that's all I wanted to show you. Now I want to verify what we talked about earlier, that, let me do this real quick. This 3-point test. We're going to check the battery voltage, we're going to check before the load, and we're going to check after the load. And I always kind of joked with my students that, you should tattoo this on your arm too. This is to be counted on every time. I'm going to go to the battery with my meter. I'm going to select 20 volts. Actually, and then I'm going to come down and test the battery first. I said I wanted to. What's fully charged battery? Jeffrey?
Yeah. I'd be a little happier with a little higher, but you do have a load going on, so.
Oh, I can go high. This knob is really sensitive though.
Yeah, that's
so
fine.
6, 7. I gave you one extra one. How about that?
Yeah.
So check the battery. That was Number one. Number two is before the load, our expectation is that it arrives. Whoops.
Trying to get
arrives
something
close
done here and I
to-
can't do it with.
It arrives close to source voltage at the load. So I'm gonna bypass all this because I don't really care yet. I don't know, right now this is a functioning circuit. We're going to put some faults in here in a minute, but right now I don't want to, I can't see all this in the car and I don't want to worry about it. I want to go right to the load because I want to check there first. And I'm telling you, that's where we go to diagnose where to go after that. Test before the load, pretty close to the same amount. And then we said what, after the load, darn it, that we're going to be looking for close to zero, correct?
Yeah, I always say it's zero or something that looks like zero. And of
So
course,
in this case,
yeah.
go ahead.
And
Go
of course,
ahead.
you explain that. And the resolution of the meter, if it's really zero, if it's a loaded circuit, we're trying to impress on the student that if it's a loaded circuit, if there is any current flow, that cannot be zero. It's measurable.
This tells me there's current flow. My eyes tell me that. I can
Yes.
put a meter on there, but eventually you're going to figure out if you see the whether it's performing correctly or not, it doesn't even matter. There's current flow.
So
So
what I'm asking the student to do,
yeah.
Tim, I'm going to interrupt you just a second again.
No,
What I'm
that's fine.
asking the student to do to be so discerning that they know that eventually they learn to go up and range the meter, because zeros, if there's current flow, it's not possible.
So I've got technically no voltage, but I see current flow. So I'm going to change, I'm at the decimal points right in the dead center there. I'm going to move it in this meter. I have to go a couple times. I'm going to come back on the other side. Now I've got the decimal point where I'm seeing 2.5 millivolts. It's changed the range, but there is some activity. So I've saved as an electron 2.5 millivolts to travel this wire back to the battery. And I made it back to the battery because that's lit. We're going to talk probably a little bit more about current tomorrow. And in all reality, I'm not alone. I have friends that travel through this wire with me. And how many friends I take is how much amperage, etc. But we're all the same voltage.
Yep.
Okay.
Tim, could you do
Yes.
one thing for me? Because I'm a little ADD myself. Turn the switch off. So this is a demonstration to the student. Bam, right there. No current flow, no voltage drop. Turn the switch back on. Current flow, we have a voltage drop. I just always want the student to be clear on, because ground sides, people disregard the grounds, and we know as technicians and as teachers that we need to stop that behavior right now because it's going to get you, right?
Right, really, and the coolest part about this is it's going to show you, this test will show you when you get a certain reading on the ground side, it's like an alarm. It's where your problem is. So real quick, in essence, let's talk on a functioning circuit here just for fun. I want to do a real quick a voltage drop test, and I know you were real big on ground reference voltage drops. So technically that means leaving my DVOM stabbed at the battery post is what I always say. It's grounded, and then I'm going to go around with my meter and compare. Really, what you need to tell your students. All they're doing when they make a voltage measurement is comparing the difference between the two leads. Okay. And so in this case, this lead is on the negative side. I'm going to go to the positive side. And I'm showing that the difference between those two leads is 12.6. As I come down to the switch, it's still 12.6 when I'm referencing ground. Through the switch, it's still 12.6. When I get to the load, it's still 12.6. Now the voltage has been technically dropped over the bulb. When I leave here, it should be closer to this. And actually, in reality, if you look at this, there's this wire, my DVOM, see if I can do this without totally. This wire is the ground. My DVOM is doing this number. And you've seen this slide already, so it's kind of spoiled it, but it's a bird on a wire. And I say that in that, let me show you something else here real quick. Let's go back. That was ground reference. If I found a problem, I would pick up both my leads and actually start walking down the circuit and trying to figure out where it's at by comparing these two leads on sections of the circuit. So I'm going to do almost the same thing I did just a minute ago, except now, instead of getting a voltage reading, I'm going to check this wire with my meter. Well, that looks stupid. You're connecting to the same wire. Why would you see really anything at all? Fair enough. I mean, it's a wire.
Yeah, but that would be the reinforcement that I would do, that there is current flow, there is a voltage drop, and
it's still ranging in millivolt now too, so it's a very small amount.
Right. All you have to do on this demonstration that I would do with students is just unplug the positive lead out of the light socket.
Okay. Well, I'll do it a different way. How about that? I'm getting ready to do that.
Okay.
So just play around here. I used to say bird on a wire. How come a bird can land on a wire, a power line, and not just fry like a chicken? And it's because both feet are on the same wire and there's no potential difference between it. Just because I thought I was funny, I used to say, whoops, bird on the wire. Made them remember me anyway. But let's go and do what you're saying. I'm going to come down here. I'm going to pick this lead back up. I'm going to go to the next deal, which is really a functional test. I'm going to go over the switch. Okay, because switches can fail. They can get bad connections, contacts in them. There could be the plug into it. There could be a lot of reasons why a switch fails, and you can do a voltage drop over. Right now, there's current flowing, and again, another tattoo is, what is a voltage drop? It's the loss of voltage by passing current through resistance. All three players have to be available and active, or you're really not doing a voltage drop. Now, I'm checking across the switch, and there's very minimal, I guess, amount of voltage drop. I'm going to do what you said, and I'm going to unplug that lead. I'm just going to open the switch. Same thing, right?
Yep.
What are we expecting?
I expect zero, because there won't be any current flow.
Well, okay, then right there, we're getting a 12.67 reading. Is that a voltage drop, or is that?
No, that's the correct reading because the circuit is through the light bulb. So I didn't see the.
No, that's okay. I had a big discussion with Vince about this one time, because I said, how does it know that it's not reading backwards? How does it know it's reading across the switch or going the other direction? How does the meter know? And he said, the meter doesn't know anything. The meter just knows the difference between the two. And in this essence, we're going back to the battery with this one, and we're going to ground really through the bulb and all the way back down. So we're seeing the potential difference between there and there on the meter. And it's not technically a voltage drop, right?
Nope, it is not.
But the application is, and we can tell now because the light's off. But think about this: if in the real world we ran into a situation where we're trying to find this voltage drop, and we're going back through the circuit, and let's say this isn't a switch, let's say it's a connector, a harness connector, and we back our way up until we find that there's voltage on one side of that connector, and actually we're touching it like this and we're getting a 12-volt reading. Customer complaint, that particular, in this case, it's a motor. The motor isn't working. We're getting a 12-volt reading. That's a wire. We're a bird on a wire. Both our feet are on the red wire. There should be no reading on that meter, but we're getting a 12-volt reading. That tells me that inside that harness is an open, technically. And it could be any variety of 12 volts. It could be 8 or 9 or whatever, but a 12-volt would almost indicate that wire, that harness inside there, that plug-in is burned or something. Correct?
Yep.
And what I was telling you yesterday, man, I did it for so many years, and I would have probably just unplugged that thing first and started testing. And that's the equivalent of, I use the analogy of a Cub Scout troop coming into a crime scene and stomping around before the police get there. It just disturbs all the evidence, and there's no way to tell really what happened. You would unplug it and go, and then plug it back in. Everything started working, and you'd say, well, I don't know. And then you go to the service advisor and say, well, it's working now. Let them take it and see. As a service advisor, shop owner, whatever, I can't sell, I think we fixed it. I can sell, we fixed it. And when you see it with your meter here, and I used to tell my students, this is where you stop and generate your paycheck. Yes. You confidently have done this test, and you say, I know that shouldn't be a reading. It is a reading. I'm not disturbing it until the customer okays some time. And it might be just a matter of pulling it apart and cleaning it and putting it back together. But you found it, and they didn't, and they pay for your knowledge.
Yep.
Fair enough?
Yes.
But yeah. once you jack with it, then and plug it in and everything's working great or whatever, then that's a tough one. So
I got our friend Dan Benson. I have to say something that he always says to the student. You got this module, whatever it is, and you've said that it's that one. It's that.
Yeah.
Okay.
Yeah.
So that's a $1,500 piece, and you're ready to charge this. All confidence is on this piece. And of course, the one that he took out of a new box, but he had already faulted it. So he gives the new not good piece to the student, and it doesn't fix it.
Yeah.
So, you're really making people think, because, at some point you need to introduce the term that new doesn't equal good.
Right.
And we have to be able to test.
Well, and what we're talking about this week is I don't want to say the easy stuff, but it is the easy to be sure. You're eventually going to get to a point where, and I read an article just this week that said, what about the undiagnosable? And cars are getting to the point where, when you filter in electronics and CAN bus and things like that, obviously, there gets to be a point, and I think hybrid cars kind of led the path on this, where they get you, they'll walk you down a diagnostic trail, and they'll say, at this component, here's your readings. If it's still not working, replace that component. And that's, I think, where a lot of our industry is going. But if you replace that component and it doesn't fix it, then I call that undiagnosable. If all the service information you had got you to that point, and it said replace it, and it didn't fix it, then what do you do? And that's the scary part. We're so far on the other end of the spectrum with what we're talking about this week that it isn't funny. I mean, we're trying to get just the basic skills to where you can fix, a good percentage of the electrical things, but you can't, we said this before, Jeff, that you can't go CAN bus, you can't go electronics until you understand this stuff. And you have a really good feeling for this stuff, because you don't want to get beat up. You don't want to get beat up by a low battery because, on whatever. You just have to have a strategy, I think. So
I think that you fix maybe 85 to 95% of your electrical problems right here. It doesn't.
Yeah.
It's not more complex. I mean,
no, I get it.
I've seen too many of those open battery cable pressed on ends with corrosion.
Yeah. Oh yeah.
And,
yeah.
That have been ignored.
So to verify before I go to the service advisor, that and we're running out of time. We'll do this tomorrow. I'll put faults in here, and I'll show you how it totally is visible by this guy right here. And I call it instrument flight. You're going to learn to trust that. But right now, while we're still here, I'm going to just verify it and say I'm going to go for each section. And I like putting the negative lead closer to the negative side, mostly because it doesn't make a negative number on your meter. That confuses students. But for the most part, I'm going to kind of walk my way around. And so really, this is a wire. There should be no voltage drop. Minimum 2.5. I'm okay. Nothing I'm going to derail this diagnostic strategy for. The switch has a little bit, 0.9 millivolts. This wire going to the bulb has another 2.5 millivolts. Now, I'm hoping we see a ton here. It changed ranges on me, and it went up to 12.64. So all those little bitty millivolts that we've been adding up are going to be the difference between 12.64 and our source voltage. Now I'm going to turn around and go positive to here and go to the battery and check the ground. And I'm happy with that whole circuit. And in all honesty, there wouldn't have been a customer complaint. It's working as designed. The engineer wanted most of the voltage drop right here, and we verified it by proving it right there.
Yep.
Now I can go to a service advisor and say there isn't anything wrong with this, particular circuit. Customer might have a complaint, but it's working fine right now.
Cool.
Fair enough.
Yep.
So, Jeff, we didn't get as far as I wanted to get today. I had 7 different demos and we got through 2 of them. So
yeah, I think the key thing here, Tim, is we really can't move beyond this until they've got this. I know I keep saying it, and I'm a broken record, but that was the bare minimum of what I thought a student should be able to do before they walked out of the door, is be able to consistently troubleshoot simple parts of the system. And then they can scaffold up their learning, they can do other things, start to understand the things that are required to understand, like a CAN bus communication system, stuff like that.
Well, and what we talked about here today, and we're just really kind of introducing this. You have to continue to do it. You have to practice it. I've said this before too. I took Taekwondo for quite a few years, and the grandmaster that was teaching me said when he was growing up, and he grew up in a Korean family. I mean, they lived and breathed this. I think he did, a sidekick coming out of the womb. This guy was good at it. But he said his dad used to make him go to a wall and punch, not the wall, just not hit it, just do the motion of twisting your wrist and getting it to where it's just totally reflex. Not even think about it. Bam, you just did it. And that's kind of what I like. I tried to instill in my students that you need to do this to where it's going to, what you're doing every time. Get a strategy, and then when you're going, gather pieces of information. Like I was telling you yesterday, Jeff, millivolts. Okay, I'm going to put them on this shoulder and remember that we've got a millivolt drop, but I'm not stopping my quest because that's not enough to derail me. I'll show you one tomorrow that's going to derail me. We're going to stop and fix that before we go any further, and that's just the way it is. So, yep. But knowing that difference is an acquired skill. That's all there is to it. So,
yep.
I'm going to stop
Jimmy.
But there's some guys who are saying, hey, they've got time if you wanted to get into a couple